Today we'll be filling out our guided notes about direct variation. Take a moment here and record the definition that I've written on the top of the page. Direct variation, a math relationship between two or more variables where one variable can be expressed as a product of a constant and the other. Pause here to record that definition. So here, for number 1, we see that our relationship is y varies directly as x. So this is our relationship. One way that we can write this is to write that y1 is equal to k times x1, where k is our constant. We could do the same thing for another set of x's and y's. Let's say y2 is equal to k times x2, where again k is our constant. We could solve each of these formulas for k, and we would end up with y1 is equal to x over x1 is equal to k. And doing the same thing here, we would have y2 divided by x2 is equal to k. Setting both k's equal to one another, we then have y1 over x1 is equal to y2 over x2. And this is the relationship we're going to be using to solve our problem. So if we look up at the top, we see that y is equal to 16 when x is equal to 4. I see the word when. When is our linking word. I'm going to call this y1 and this x1. I also see that they want me to find x when y is equal to 20. So here is my linking word, and I'm going to call this x2 and y2. Plugging into my formula then, I have 16 divided by 4 is equal to 20 over x2. You can use cross products then, or as kids like to say, cross multiplication, to find that x2 is equal to 20 times 4 divided by 16 is equal to 5. And as I said before, the nice thing about videos is you can pause them anytime you need to catch up. Let's take a look at number 2. If y varies directly as x, there's our relationship. We have y1 is equal to a constant k times x1. And we can use the exact same formula that we used above. So let's write y1 over x1 is equal to y2 over x2. Here I see that y is equal to 9 when there's our linking word, x is equal to 6. We've got the same thing going on here. We've got y when x is 8. So we're going to call this y1 and x1. And here y2 and x2. And plugging in, you'll find you have 9 over 6 is equal to y2 over 8. Again, using cross products to solve, you'll see that you can take 9 times 8 divided by 6 gives you that y2 is equal to 12. So that takes care of the first two. The relationship for the last one is a little bit different. It says y varies jointly as x and z. So our initial equation would be y1 is equal to k x1 times z1. Rewriting that equation again, we would have y2 is equal to k times x2 z2. Solving for k, we get y1 over x1 times z1 is equal to k. Doing the same thing over here, we get y2 over x2 times Z2 is equal to K. Setting both of these K's equal to one another, we come up with our formula Y1 over X1 times Z1 is equal to Y2 over X2 times Z2. Now our only problem is deciding what's going to be 1 and 2. There's my linking word when. Here's my other linking word when. So I know that all of these y's and x's and z's happen together. All of these y's and x's and z's happen together. I'm going to call these y1, x1, and z1. And these y2, x2, and z2. Plugging in, we find we have 10 over 2 times 4 is equal to y2 over 4 times 3. This becomes 10 over 8 is equal to y2 over 12. And solving for y2 using cross multiplication, we get 10 times 12 on the top divided by 8 on the bottom, and you end up with y2. My bad, I am off screen, I'm so sorry. You end up with y2 then is equal to 15. Take your time, complete all the rest of the problems on this packet. Please show your work neatly, and box your answer. Turn it in before you leave.